Hey everybody, this is Larry. This is me over Q4 of the weekly contest 301. Count the number of ideal arrays. So yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. This problem I was very, I want to say rusty on. I didn't solve this during the contest, but I think I was just one. It's kind of weird because, not weird, but it's just the way I've been. Maybe I've just been on a slump. But basically I had all the ideas, but I think I was missing one, like putting them together in a good cohesive way. And I'll talk about how I solved this. This is a combinatoric problem, so definitely there are a couple of ways you can do it, but this is the way that I did it. So the naive thing that I tried to do first is kind of, just brute force, right? Or brute force with dynamic programming. But given that the value, and you would write something, and I kind of did write this. So if you look at the problem, and I would say, as usual, you could watch me solve it live in the contest. But to be honest, I really wasn't doing anything for most of the hours, so definitely skip ahead and maybe look at only the last maybe hour or half an hour or something like that, where I was like, okay, and then I got it, and then we'll go over the code here. But if that's what you want to see, and you want to see how I learned, then yeah. I actually did try to look at code from other people, but I don't think this is one problem where just reading at it, I don't think it's easy to understand unless you already have the foundations, which hopefully I'll be here to provide. So definitely let me know in the comments if you appreciate this video or not, because this was very painful for me. Just a rough day, but basically the idea that you can have is that, okay, so then the last number is you last number, and then the last number, and then left, basically how many numbers that you have left in the sequence, right? And of course then here you can just do something like, a for loop for x, and this is very rough for loop, right? So basically you have, maybe let's just say a multiply is equal to 1, while multiplier times last number is less than max value. Count total, we added to count of multiple times last number, and then left minus 1, right? And so forth, return total, pretending that, and then we add memorization and stuff like this and take care of mod, right? So this is basically the first idea that I had. I mean, I knew this was going to be too slow, but I just wanted to implement it out, because sometimes, especially for these primerization or prime factorization or factorization problems, there are definitely a lot of sometimes things are n log n, and I'm always really bad at analyzing it. I think that's my thing. Though in this case, that's not true. This is still n log n, even if you do memorization. So the first thing that I did was, or the second thing that I did was I convert this to go backwards. Instead of now going to the last number, I look at, okay, so I had something like this where now we're going backwards, right? So I do something like multiple is equal to 1, total is equal to 0, same idea. But now we go while how do I do it? Something like this, and then total we incremented by count, and then last number divided by multiple left minus 1. This will also work, except for it's also too slow. Same problem. But I was hoping that maybe doing it backwards, there's some way to optimize it. This is basically the same idea, except for now you're counting from a bigger number, from the last element of the array to a smaller number. So that's another way that I did it. This is still going to be n squared, at least, even memorization is actually worse than that. But yeah. So right about now, I actually did figure this out during the contest, but I didn't really put it together, to be honest. And what I mean by that is that now, let's look at some sequences, right? So, mostly because I was missing one observation that I don't know about usually, but I have made in the past, but I didn't make it on this problem with respect to these numbers. And now, yeah, so I'll go over that in a sec, but let's say the last number is 5, right? Well, then that means that there are a couple of ways to do it. Actually, let's choose another number that isn't a prime. So let's say 12, right? Let's say last number is equal to 12, and we can, let's say n is equal to 4, okay? So then that means that, well, what are the factors of 12, right? It's 1, 2, 3, 4, 6, 12, say. And there are a couple of ways you can do it, but this is the way that I have it. Yeah. And what does that mean? That means that if n is equal to 4, you count the number of paths that it can happen. So now it means that, okay, well, you have to choose 12 as the last number because that's the definition of how we construct it. So that means that now, given 5, yeah, sorry, I just have to make sure that I didn't want to say the wrong things and confuse people. That means now there are, 3 spaces and a 12, right? And then how do we break it down? Well, so this is the part that I did get during the contest, but I didn't know how to proceed because I was missing some insight, which we'll talk about in a second. But basically now, well, how many, how do I say this? Basically now here in the spaces, how many distinct numbers are there, right? So how many distinct numbers are there? Let's say keeping in mind that spaces is equal to 3, right? Because the last one is, we use the last space, right? And here then we don't want to use 12 again because, well, we can use 12 again actually. But it depends how you construct it. But okay, fine. Maybe I confused myself here. So okay, let's just say space is equal to 4, but one of them has to be a 12, right? So then now how many distinct numbers, how many ways are there to get to 12, right? So let's say we have to use 4 numbers. What does that mean? That means that we have 1, 2, and then 4, 12, 1, 2, 6, 12, ... right? So these are with 4 distinct numbers. 1, 3, 6, 12 as well. There may be more, but I'm doing this manually, so so forgive me, right? So now let's say we have 3 distinct numbers, right? What does that look like? Also, let's see. No, maybe this is it. I was trying to think whether I missed one. And then now 3 distinct numbers. So now let's not worry about the spaces for now. Let's count how many ways are there to do 3 distinct numbers. So so 12, there's 2, 4, 12. There's 2, 6, 12. There's 3, 6, 12. There's 1, 2, 12. 1, 2, 1, 3, 12. 1, 4, 12. 1, 6, 12. Something like this, right? So I don't know that I got all of them, to be honest, but this is roughly the idea. And then 2 distinct number is easier numbers. Well, not easier, but just 1, 12, 2, 12, 3, 12, 4, 12, 6, 12, right? Again, I may miss the number, but yeah, 1 distinct number is going to be 12, 12, right? Or just 12. Okay. So, okay, right? So then the question now is that for each of these, how many ways are there to count them, right? Meaning how many ways are there to fill up 4 spaces? And this is where you do bars and bars and stripes or stripes and bars. I actually don't name it that way. I always forget the name that, because when I learned it in combinatorics when I was young, I think they did use that name once, but in the class we called it something else. So anyway, but here it should be obvious. Each case there's only one case, right? Because there's no space for changing. Here there are 4 spaces. Right? There are 4 spaces, and you have to put 3 bars. And keeping in mind that because each one has to be non-zero, you can, usually or very commonly, and I'm okay. Actually, maybe slightly cleaner. Yeah, and this is I do recommend reading up. Was it stars and bars, or bars and stars, something like that? Just Google this a little bit if you want to get a more idea. But here, because you're forced to have at least one element, this we cannot have. This is not a usable space, and this is not a usable space. So now you have 3 spaces to put the gaps. Meaning, what do I mean by this, right? Meaning that if I put the break here, then yeah, then you have, for example, you have 1, instead of using this, you have, I'm just going to use A, B, and C for a little bit of visualization. So then the three ways you can do is A, B, C, and then A, B, B, C, and A, B, C, C, right? Oops. And of course here, I just mean that I put the two bars here, and here I put the two bars here, and then here I put the two bars here, just to be sure, just to be clear, right? And so that means that there's three ways to do this, meaning, you know, 1, 1, 1, 2, 12, dot, 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 and then this is 3 and so forth, right? So that's basically the idea behind this. And if you generalize it, looking here, let's generalize it for a second. We have 4 spaces. Oops. So that means that we have 3 stripes, and we want to choose one of them to divide the 1 and 12. So that means that this is 3 choose 1. And the same way here, maybe I didn't say it very well, but here we have 3 numbers, right? So that means that we want to put bars between 2 of them. That means that we have to choose, and here we have 3 bars. We want to choose 2 of them, right? So this is 3 choose 2. And this is 3 choose 1. And the same idea here, though I guess, you know, this is 3 choose 0. So, you know, that's going to be just 1, right? And this is going to be 3 as well, dot, dot, dot. Right, so that's basically the idea. Of course, I do recommend reading star and bars on the Wikipedia, and it will give you an idea here. But that's basically the idea, right? Is that, and here, just to be clear, you know, you have you have. Maybe I should have used stars instead of, I'm using stars and space instead. So maybe that's a little confusing. But yeah, but there are 3 bars, and because we have 3 divisions for, we have to choose 3 of them. So it's 3 choose 3. Right? That's basically the idea. And now we just have to sum it all up, right? For the number 12. And yeah. So here, as we said, because we have this 3 choose 3, 3 choose 2, that's easy. So then now the question is, what is the observation that I was talking about that allow us to get this problem? The observation that allows us to get this problem, and I actually did this a little bit in if you watch me solve the problem, I kind of looked at it, is that each number between 1 and 10 to the 4th will have at most 60 factors. That means that, yeah, there were at most 60 of, well, I mean, you can only go up to, so there are a couple of ways you could phrase it, but the way that I'm doing is a little bit lazier, because it's more of an upper bound, because in theory, at most, this will have only 14 or 15 numbers because, you know, if you double every time, say, you know, 2 to the 15 is already going to be way too big for this, or big enough. But yeah, the way that I did it is a little bit different. So I think it's still kind of true. It's just that the proof is a little bit different. But yeah, but the biggest number will have 60 factors. And from those factors, we choose one. And then the recursion here will be basically, well, I'm just going to go over the recursion then. I don't think I mean, I was going to write the formula for it, but then we'll just go over the recursion, right? But basically, this is the recursion, right? For each number x, how many ways are there to have a path of y elements, right? Or when I say path, I mean these things, right? Let's say, because now we're brute forcing, essentially. Let's say last number is 12. How many ways are there to have 4 different numbers? How many ways are there to have 3 different numbers? How many ways are there to have 2 different numbers? How many ways are there to have 1 distinct number? And that's basically what we have here, right? So, for example, in this case, we have go of 12 of 4 is equal to what we had before, right? Is equal to this thing. And that is just equal to, for example, so the last number is, technically, we actually, yeah. So then the next number will have to be something that's not 12, but one of the factors. I do it this way, but it's the same either way. So it could be 6, 3 plus go of the last number was a 4 with 3 numbers. Or basically, this is using a 2. This is using, actually, not even using a 2. Sorry. But I mean, we use a 2, but the factor is just that this is now, you know, numbers of 12 and 6. How many ways are there where it's 12 and 6, and this is 12 and 4, and then goal of 3 with 3 numbers left is 12 and 3, and so forth, right? I mean, some of these will be impossible, but for example, I think this is impossible to have 2 more numbers, but that's the idea, right? And here, of course, what is 6? 6 is just, you know, going to be either 4 with 2 numbers left, or actually, I guess 1 number left. This is already using a 12, so maybe I'm off by 1 here. Sorry, friends, for confusion. So 4 numbers plus, you know, this is actually wrong as well, because 4 is not a factor of 6, but 4 and then go of 1, right, with 0 numbers left. So then this stack means 12, 6, 3, 1, which is what we have here, right? So this is almost like us doing brute force. And then here, for example, we will have go of 2, 1 plus go of 1, 0. And this is, of course, just 12, 6, 2, 1, right? This is 12, 6, 3, 1. I think I'm missing 1 number. 4, 2, yeah. No, this is this one. Oops, I wrote 6 here. That's why I got confused. But yeah, and then here, of course, there's also another one, which is the one that I missed, plus right. So then now, because all the other ones will, you know, return 0 because it doesn't go to left if it is equal to 0, because we just don't, you know, go that way. This will go of 12, 3 will return 3, right? So this is equal to 3, and then now, how many ways are there to do these? So there are 3 ways. How many are there ways to do each individual ones, right? Well, that's going to be 3 times 1. So this is so then now the number of ways to have the last number being 12 and 3 distinct elements is just equal to you know, this go time. This is confusing. Sorry, I'm going to write this here a little bit. And then here, it's just going to be it goes to this 3 times 3 choose 3, because as we said, we have 4 spaces, which means that we have 3 bars, and we need 3 of them to separate the 4 numbers. So 3 choose 3 is equal to 1, so we have 3 in total. And that's basically the idea, is all these kind of brute force to kind of get you this idea, right? So first of all, if you have, maybe I'm a little bit late in introducing it, but the way that I did factors is by using CIF, right? Oops. Error standards. Maybe I spelled that wrong. Let me. I spelled that wrong. I did spell it wrong, really wrong, actually. Okay, but yeah, so Wikipedia this as well. Also, you know, stars and bars. This is a lot of math put together. That's why it's kind of hard. Okay. So then now, so we use this to do factors by going, okay, the idea behind this is very quickly is that for each number we go, okay, let's look at. For number 1, we set it as the factor of 1, 2, 3, 4, 5, ... For number 2, we set it as the factor of 4, 6, 8, 10, ... and so forth. That's basically how it works, and that's how it updates. And maybe surprisingly, maybe you don't know, but this is actually one. So given that max value is, let's say, m, this is going to take m times plus 1, or m over 2 plus m over 3 plus m over 4, ... right? Which you might not know this, but I'm telling you now because I always have trouble doing it. This is going to be m log m roughly. So this algorithm will take m log m, so it'll be fast enough given that m is only 10 to the 4th. This code we already talked about. This is very short dynamic programming. Let me not lose the cache here. Dynamic programming, and it basically, with this cache, it just remembers the dynamic programming so that if you call this again in the future, you know, it saves it, because every possible, for the same possible input, you get the same possible output. So that's basically the idea here for this one. Yeah. Cool. And then the remaining part is there's so much math on this one. I mean, like I said, the individual parts are doable, but it's kind of annoying that you have to know all this stuff, because I would also say that most of this stuff will not be on the interview. So yeah. And here we use something called modular inverse. And modular inverse, I'm not going to get into in a little bit, but it basically lets us do, for example, it lets us do 1 over x. Let's say 1 over, let's say we have k over x and we don't want to mod it by some mod, right? This is the same as k times the modular inverse under mod, assuming that this is an integer. That's basically the idea. I'm obviously hand wavy and a little bit quick on this one, but definitely look it up. And the idea that what I use for modular inverse is by calculating both the factorial of, factorial of I factorial so f fact of I is equal to I factorial, and then I fact of I is equal to 1 over I factorial. And the reason, under mod. And the reason why that I need this is so that we can do choose. And choose is just, binomial formula, which is basically n choose k is equal to n factorial over n minus k factorial times k factorial, right? Put the parentheses in the right place to make sure. Like I said, this is a lot of math. If feel free to slow down and pause or whatever you need to do and do the Googling necessary, right? This is just, let me write this again. This is binomial formula, something like that. I'm doing this off my head, so my apologies. But yeah, and this, of course, as we have this modular inverse proof here, the idea is that, so now this is just n factorial times, the inverse of this times this, the inverse of k factorial, right? So that's why I have it here, and then you can mod it very easily afterwards, right? So that's basically the idea here. And here, this is just brute force again. This is basically for each value, we go, okay. So the last element is I, and here I start with total is equal to 1 because this is the last element is 1, which is just 1, 1, 1, 1, 1, 1, 1, 1, 1. So it only has one entry, right? So this is why total is 1. So the last element is I, is what I have here. And here we have, how many ways are there to have the last element being I and have j distinct elements in the sequence? And this we already talked about, which is that, this is going to, so here we brute force every possibility of, okay, for every number up to max value, we go, okay, so let's say the last number is I, how many ways are there to have j minus 1 distinct elements? That's basically all this is saying. And then we times it by the number of ways to kind of separate them in that way. And that's pretty much it. This is basically the entire problem. I spent a long time doing this. During the contest, I didn't get it. The key part, though, that I kind of forgot, I don't think I talked about this actually. The key part about this, and we'll talk about this in terms of the analysis, is part of this, right? So the key part that I forgot or missed about is that, well, I did it really in this way, but okay, let's analyze this. Sorry, I'm a little tired. Let's analyze this a little bit, right? What is x can be, right? X can be from 0 to max value, so let's just say 0 to m. Left can be, so this is the part that I didn't put together. I didn't know how many numbers there are, or I didn't, not that I didn't know, but I didn't think about it explicitly. And in the past I would have, but here I did not. And here left can be, and I did, if you see me did a loop, I took a max of all the factors, and the max factors is actually 16. Oh, sorry, 60 something. So, but this is actually not even the upper bound, because like we said, not even the tight upper bound, because like we said, let's say we divide it by 2 every time, right? So let's say we have 10,000 and we divide it by 2 every time. Like we said, this is only 2 to the 14, right? So that means that after 14, this will already be 1, and we would have no other factors other than 1. So this actually doesn't even go that high. This is actually only up to 14, though I put in, I mean, this is a little bit inefficient, but it's still only up to 14 or maybe 15. Maybe I'm off by 1, right? So yeah. So this is actually higher, but again, this can only recurse 15 times. Yeah. But okay, but let's put it in 60. So that's the part that I forgot about. And if I had done it, then I would have put it together. Because this part I knew how to do, the factorial stuff, the combination stuff. I knew how to do. And I was in my mind, but I just didn't code it out. So this was the part that I missed. But yeah. But in this case, because just knowing that this is 60 means that now we can solve for it, right? Because what is the time complexity of this? It's equal to total time times number of inputs. And the number of inputs, as we said, is going to be m times 60, say. And each input takes all of the number of factors time, which is 60, right? So let's call it f for now, for max factors. So that means that the total time complexity is equal to O of m times f, right? And because this is going to be 60 times 60 times, and of course, like I said, most numbers are actually even smaller. Most number has fewer factors. So this is a very not tight bound, but this is just 10,000 times 60, which is actually 36 million. So it's a little bit high, but like I said, most of these will not be reachable. So that's why this is good enough. Yeah, but let's just say this is O of m times f. Yeah. And this part is going to be O of, which one? O of n, as we say, O of n times and O of n space for the factorial and the loop to calculate. This part, as we already said, this is going to be O of m log m space and O of m log m time. And then lastly, we have this part, which is O of m plus f, times f, because that's just the 2 for loops. And here, these are all 1 operations because we have it memorized. So yeah, so this is O of m times f time, and space, this is just O of 1 space. So putting it all together, this is how you would solve it. It's very tricky. Like if you notice, I put in a lot of like names and ideas and stuff like this. So this is a very hard problem with a lot of math. So don't feel so bad. I didn't get it, right? So yeah. So the total time is going to be m times f for the dynamic programming, plus m log m for the CIF, and I think that's it, or plus n for the factorial stuff. And then here we have for time, and for space, I think it's just m times f plus n space for the factorial stuff. Cool. Like I said, just to kind of give a quick review, because this has been very long, because this is very hard. You need to know CIF for this one. I forgot how to spell the name again. I don't know why. Yeah. So you need to know CIF. You need to know modular math, including modular inverse. You need to know combinations, which is also binomial, and maybe stars and bars, and is that it? And I guess dynamic programming. So this one is very hard as a result, and also just taking note that dynamic programming and maybe even like what's it called, basic number theory with factorizations, max factors, etc. Yeah, so this is pretty much it. This is why it is hard. And what I was missing was just this part with max factors. I think I did do something with max factors, but I didn't put it together, like I said. And yeah, because I got to all the other parts and I was thinking about it, but I think I just missed this very short function. And if I had done this, then it would have been, because I had versions of this, but not this exactly. Yeah, and you could kind of see me. So you could see me solve a live in contest next, but to be honest, I solved the first 3 problems in 10 minutes. And so the first 80 minutes of the next part, I didn't solve it, right? And I didn't really even give good attempts at it. And then someone told me about, and props to Josh, told me about the max factor being, well, he said it was 15, which is true. But then that already sparkled that, okay, now I know how to do it, because now I remember that I can just do a brute force on it based on the combination. So yeah, this is kind of a lot of brute force things put together with so yeah. This is a very, 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 very hard problem. You know, a lot of people got it. So I don't know. Like I said, I don't expect this to be on interviews anytime soon, so take it as you will. But that's all I have for this one. Remember to fast forward and skip ahead for the next part. But you could watch me just like beating myself up for 2 hours coming up now. Confident, but okay. Better lucky than good today. Okay, you give an N and max Y. Someone already got this. Why are you from 1 2? Divisible by the last one. Okay. And it's 5 exactly. 10,000 is gonna be too small, too big. Or 10 to the 4th is what 10. Yeah, 10,000 squares is gonna be too big. So we probably have to do something slicker. Well. You think? Maybe not. No, I mean that's still a lot. Right? Maybe it's not actually. Let's see. Still a mod thing. Yep. I didn't actually missed it, but mod. Okay. So now we want to. We just assume that we don't go. Maybe I don't know. I don't know if this is right. To be honest. This is gonna be right, but is it too slow? I was wrong about it being right. Oh, I didn't actually return it, that's why. But oh well. this part's an easy fix. 10 and 11. Oh wait, that's right, but is it fast enough? Right. Yeah, maybe not, because you can just, so you have to make one observation maybe. I mean, okay, we have to do some mod, but maybe that makes it fast enough. That would be amusing. I actually messed up that time. Should have checked that first, but still should be too slow. Maybe I thought it would be too slow. How many people got it? Okay, a couple of people got it already. Is it better to go max value the other way? But it's still going to be the same, I think. Yeah, I mean, each one is going to be log n, but then there's going to be too many of these. Am I missing something obvious? I mean, this is going to be the same as any other way, right? I see. Maybe I can do something the other way. Because then now maybe there should be log n. Okay. Yeah. Okay, now we have the max value, then we have Am I doing this quite right? I don't know that I'm doing this right actually. No, because you want to do times 2 and then times 3. It's not this. maybe this is weird. Also, it's just wrong. Wait, this part should be right, I think. But this part is just very weird. Well, a lot of people got this one. I do not know how to do this one. Okay, what does that mean, right? So max value, let's say it's 10. 10 and 2, 6, right? So that's just trying to get this right to see if I can optimize this, but clearly I'm not even getting close to it. I think it's something like this though, but maybe I'm just being really weird. Okay, let's think about it backwards. 10,000 array elements. We look at the previous one. That's still going to be 10 to the 4th square though. I don't know how that's faster. We're giving the max value. Right. 1, 2, and then divide it. No, this, I feel like this is right, the idea. If not, the execution. This is too much. This is too much. What does that mean? Now this is too little. Start with 5. 5. 1 number left. That means that is 1. 1, right? That is 2 because it's 1, 2, 2, right? No, I don't think that's right. 5, 1 should be 5, I think. Okay, so this one is right. 5, 2 is 10. Why is 5, 2, 10? Oh, 5, 2 is just everything, but okay. Now you have 2, 1, 2. 1, 1, 1, 2. Okay, that's fuse right. 1 is 1. First number being 2 with 2 numbers left. Oh, that's not right. Okay, so now this is right, but is it fast enough? Might still not be, but at least I have the idea, and then now we can see if we can optimize this part. Okay, still too slow. Oh, maybe because I'm putting stuff as well, but still too slow, I think. But okay, but then now I can think about how to optimize this to only, instead of choosing every number, a lot of these numbers are duplicate, right? So that means that, let's see, like how many ones are there? 2 and 3, so okay. I think I have a path to compress this, and I think if I was better at math I could do it quicker, but and then now this becomes just log, right? So then now it is, let's say 5, we have one of them is 5, 2 is 2, 3 is 1, 4 is 1, 5 is 1, right? So that means that okay, that means that we want to get all factors of n. Okay. Can we do it with our whatchamacallit? I feel like I've done win this before, but I don't have it ready, so I guess we have to wait it out. Yeah. Ten to the 5th is what? 10 to the 4th times square root of that is 100, so that's 1,000,000. We can do it. Let's go. This may be a little bit the dumb way of doing it, so let's not do it that way. Yeah. just want to real quick just to make sure. And then now we can do something like just do it the dumb way, Larry. What are you doing? For factors. It's not even factors, is it? Huh. Just changing the transition. So then 1, 2, the 3 is going to be 1. And then it's going to be 3 until, because we want, okay, maybe I messed this up a little bit. Because we don't want factors. We want it to go up to the square root, because after that every ring is 1 anyway. Okay. So then now we want actually, okay, something like this. And then now how do we do it, right? Let's say we have a bigger number, not 5, but 10, I have 1. I have 1 for 10, and 2 for 5, 3 is 3. I guess just, yeah, every number after that is just going to be, and we have to be careful about off by ones, but okay. I mean, I know this is going to be the wrong answer, but I'm going to see if it's fast enough. It might still not be though. I think that's the problem. Then I still have to make this faster. So I was hoping that this would, well, a lot of people got it. Just not myself. It's just too mathematical for me to know. I mean, I think this definitely makes it faster than before, but then now, but it's still too slow. I mean, this is wrong, but that's because we have to do a multiplication factor. Number 3 is going to be 3, 4 is going to be 4, and all the way through to n log n, and then there is just n of these or something like this, right? Or something like that. Maybe it's off by a little bit, but that's fine. It's gonna time out, but huh. I actually don't know if I know this one now. I do have the optimization, but the naive. I was also hoping that with this DP I can figure out if I can optimize this away. I was hoping that maybe max will have a structure, which it should. There should only be, maybe not. Maybe it's just M over 2 of these because you have 2 and then it just goes over it. So maybe that doesn't get rid of enough of it. But yeah, maybe that's just N over 2 and not. I was hoping that would be maybe log of N. Can I do this with? You could always jump ahead, right? From 1 to 3. So the naive is going to be, I don't think I can figure out the naive. The square root is faster, but it's still 10,000 squared times square root, so I have to do a little bit better. How do we keep track of the left though? Yeah, it doesn't really matter, but should I have to do some crazy matrix multiplication? No, probably not. Fast forward and transform. This isn't quite right, but it is the same right idea, I think. It is one optimization. It's not enough of an optimization. Huh. I don't even think this is fast enough to do it once, let alone like I can't do like some sort of memorization thing. Maybe let's see how long that would take, if at all. This is the answer for 2, this is the answer for 1, and yeah. Hmm. Five, 2, 1, 1, 1. That sounds about 9, 1, 1. Then when we go 9, 1, 1, 2, 2, 2, 2, 2, 2, 2. Mm-hmm. Okay, so at least now I should get at least one right answer. At least like some number to play around with. Even 100 is pretty fast actually, but I don't know if this is right. And then now even 1,000 may be too slow, to be honest. Yeah, actually, I mean, still slow, but we need to add another 0. So it's going to take 1 second, so x squared is going to take like too long, a minute? We have no idea though, to be honest. Can I do it in some sort of Sif way? I guess that was always the thought. Let's have it ready then. I feel like I've done this before. Trying to see if I can find some code, but maybe it's fine. right? That's okay. I want to file this somewhere. Whatever, it's fine. It just looks yucky, and I might come back to it. That's why I don't want to delete it like I usually do. Let's see if I can visualize this in a way that makes sense. Okay, let's start with not one there. Can I visualize this in a good way? I think it might not even be right though. Beyond like this is a very basic example of what I had before. So I think maybe we need to kick it off in a different way, maybe. So these are so you're gonna have the factors, and then what do you do with them? I don't know. Why did I delete it? Okay. I don't know that I have any idea, to be honest. So one will get this is 13. What does 13 mean? Oh, well, that's just previous. That's not really the number of total factors. That doesn't mean anything. Okay. Yeah, mine is even n cube. I don't know how to do it. So, like, I don't even have an n square algorithm. Okay. What if for each of these? What I need to do is if previous of j is equal to j, how many total possible things are there? 8,000. So I was hoping that if this number was smaller, then we could do a 10,000 proof DP on this. But it seems like that's not the case. So I try to do it. I think this is the upside down one, right? Wow, I mean, it's still 45 minutes, but I have no idea how to do it. I don't even have without like maybe it's something that I need to know. Maybe I'm wrong on that one. How many possible paths are there? This is wrong anyway. But that is just n log n, right? This number is just, yeah. Try to do something like that. So this part is not surprising. I don't know. Okay, I guess one thing I can do is see if I can figure out a pattern. Maybe that will have to be the way to do it. Let's see, right? But the thing is, like, a lot of these is depending on the number of things that are in it. I don't know that there's a easy pattern as a result of like the property of primes, right? And stuff like this. There's 5, 5, 15, 5, 15, 5, 35 is 7. 9 is what? Is this 25? No, 15. Why is this 15, for example? Because it goes to 1, 9. So then that gives me 9 of these. Or 5 of these. And then also 3. So there's also another 5. So that's 10. What's the other one? 1, 3, 9? Oh, I guess 1. No, that should be just like 6, right? Why is that different from 8? So what are the ones with 9, right? The ones with 9s are... Oh, because then now you have 5 choose kind of bordered between 1 and 3 and 9, so then it's going to be 5 choose 2, or maybe 6 choose 2, and 6 choose 2 is 15. Wow, that is ridiculous math if that's true. Because then now we'll try to figure out how many factors it has. Okay, and then let's try to have a predictive power by hand, right? So 10 has 1, 2, 5, and 10. So that means that if you think about how to divide a 5 length array, which is actually 6 elements, or 6 spaces, choose 4, or 6 choose 4. 6 choose 4 is 15, so okay, so that means that 5, 10 should be another 15 if I'm correct. 25, so I'm not right. Because it could be, oh no, it shouldn't be 1, 2, 5, and 10. That's why I'm not right, because this is 25, because it could be 1, 2, and 10. Or 1, 5, and 10. So then it's actually that's hard. I mean, what I'm doing is just like try to figure out a way to be smart, but it's not quite that way, because there are a lot of different routes to get to 10. So it's 1, 2, and 10, or 1, 5, and 10. But how do I generalize it, right? Was that 25? 25 doesn't even sound right. Oh, because but then I have to subtract the 1 and 10. So you're skipping the 1, because if I just add 1, 2, and 10, and 1, 5, and 10, I double count. So then it's 15, and then you minus the 5 cases where it's just 1 and 10 or something like that. So that's not even right. Or I don't think that's a way to go about it. Hmm. 11 is prime, so this should add another 5. Okay. 12 is not prime. 12 has 1, 3, and 4, so it can go 1, 3, 12, 1, 4, 12, and so the same thing that we set, then it should be plus 25. Wow, that's not even close. Oh, because there's also 1, 2, and 6. Okay, I forgot about 1, 2, 12, and then 1, 2, 6, and 12. Oh man, this is a mess actually. Because then now you add a lot more combinations. I don't even know how you do that without like, you know, the for loop brute force DP that we were doing anyway, essentially. And you could do 1, 6, and 12. There's just so many combinations. Is there though? No, I mean, I just don't know how to do it. It's too mathematical for me. Maybe. Apparently there's a formula for this, but I don't even know. I checked OEIS just for fun. Number of ordered 5 factorizations of n? What does that mean? But like the way that they describe it is by doing n squared, so that's not really helpful maybe. Inverse Morbius transform? What does that mean? I don't know what an ordered factorization, ordered factorization. I don't know how to do this. I have half an hour, but I've been just sitting here doing nothing for a while, so um, okay. Maybe I just don't know how to do this one. Maybe it's something mathematical, which is, and someone got in 4 minutes, so it's probably doable. I just don't know. My math is weak, so hopefully there's an opportunity to learn here. Which is kind of nice, I guess, to learn something new. Hopefully it is something new and not something weird. Yeah, I mean the n squared solution I would know. I have to come in with just n log n in a good way. But yikes, maybe today's just one of those days. No redemption. A mathematical thing. I think this is where, if I was just practicing, I would ask someone whether I have the ability to solve this, meaning that is it like some weird algorithm that I don't know about. But I don't know. And all the things that I'm reading up on Wolfram and Wikipedia, like I already kind of did. It's just the n square stuff, right? Like this also feels like one of those, like either you know you see it or you don't, because people kind of very quickly. I mean, well, maybe not. 14 minutes is like a reasonable thing. Maybe there is a testing solution for it, and Sheep Forever is like, you know, super good. Numbers got in 10 minutes. If it is some like weird hack, then I'll be very sad about it. But I don't know how to do it without keeping track of both these things. Like I can make this loop faster, but take the log. No, you can't take the log because it doesn't have to be, well, maybe that is the way to do it. Maybe I'm confused about it, but no, because there's still 10,000 square state, even if you just take the factorization of them. I'm trying to, I don't know how to do it. I don't know how to remove a dimension on this. Like I think if we remove a dimension on this, then we can do it, but even if you start with the n number, so you have 3, all my ways of doing it, unless there's some like factor, I don't think. I mean, maybe it doesn't have to be previous, but it could just look at, okay. Yeah, because if I just add size to this, it's already too slow, right? And also in this case, we wouldn't even need this to be a thing. Like we don't need this if statement. It would just be n log n, and it's fine. But then if you have to do a I really have no idea. I think this is some like if I'm able to get rid of dimension, I can do stuff, but I don't even know. Mm. That's not too slow, apparently. Oh, I get why this is the ordered factorization, because then you're just looking at the transitions. But that still doesn't help me solve it, though, unfortunately, because all these are. Because then now. I think there's a slightly optimization that I can do here, but that's I still cannot get over it. Am I missing anything obvious? I don't think so. This is very short, so. That'd be funny if I misread this the entire time, but we did run it, so. I guess this is just what it is. Really have no idea. How do I do it without another linear? Like here we would add a for loop, but that would be too slow. Yeah, I mean, I don't know if I give up. I just have no idea how to do it. Like I don't like everything I have is n square or n times max value or something. But I don't think there's a easy way to just take those numbers as to. Because then you want to sum it with those counts, and that's like recursive. That's basically what I already did. Is it something that I guess people figure it out? Huh. Good job on those people. I don't. Maths. Is there a way I can break it down a little bit? I mean, I think that this is the way that I broke it down. So. Oh yeah, actually that. I mean, it's not fast enough. Even if I made this optimization, that's the hard part for me. How? Tell me how? Oh, I really don't know. Sorry, friends. If you still 15 minutes, but I can only find. This is very sad. I'm not wrong, right? It's 10 to the 4th square is 10 to the 8th, so definitely that's too slow. But that'd be funny if all this time I was just being silly. But yeah, I guess I don't know this one, but dudes. I don't know how to work on this, so I mean I have the SIF ready. I'm gonna ask for a hint. And then see if I can figure it out from that. Maybe I'm just missing like one key observation. But well, honestly, I've been Googling, so I'm not gonna lie. Maybe that's a little bit cheating, but I was also just wondering if I was missing something that yeah. I mean, I don't think so. I think I have all the maps I need. I'm just missing one thing. It's just one thing, and then I don't know if this is. Yeah, because then here you would put n, and then you keep track of the n and then do it, but that doesn't even like that adds an extra n factor, which is already too slow. I don't know how to do it. Yeah. Wah, 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 wah. Wah, wah, wah. Yeah. If the size doesn't matter, maybe we have an idea, but I don't know. I mean, this isn't coast to right, so, but I was just trying to see what does that mean. I have to start with 1 on this one. Nope, not even close. So this reminds me of the number that we had before, but I mean, I kind of wasn't sure. I mean, I was sure that this wasn't right, but I'm just like running out of ideas and there are 8 minutes left, and I have no idea to do it. But so yeah, really have no idea. If this magically worked, I would have been like, I don't know, just WTF. But I didn't think this would work, to be honest. I should n plus 1 anyway. For the n is equal to 2 case. But still not quite right anyway. Yeah, I don't know this one, and that's very sad. What is? I'm guessing it's something to. If I have to guess, it's something like to do with this, but I don't know. It would be funny if the solution is to use another language and I just didn't think about it. That'd be funny. Let's give it a try, just because. Okay, I could do this. Why is that so fast? Was that the secret all along? Use. No, this isn't right there. Oh, whoops, that's why this is so fast. This is 10,000 faster than expected. 97. Oh, jeez. How would it even get there? Also, this is ridiculous that this is fast enough. Maybe that's what I needed to do. No way, this is fast enough, but okay. This is actually ridiculous that this is even fast enough. Maybe I should have done that earlier. At least give it a YOLO try. I don't know how to do it though, to be honest. Maybe I should have win this earlier. But okay, so what do we want to do? Right? This is long. I mean, yeah, if this doesn't work, I have nothing anyway, so yeah. And that's time. Let's see, what was I gonna do? Is that too slow? This time it may be too slow. Now that I actually have to do something. Yeah, okay. Let me ping Josh. Not gonna lie. Hang on. Let me see. Okay. I mean, I don't know how to solve this one. I want to see if I could get a hint before I try to solve this. But what? He said I don't know his solution's very weird. That's not helpful. But thanks, Josh. I don't know if he's watching it, but N-locked cube to the dirt. Alright, fine. And this is a sad one because I kind of got it quick as well. 4 minutes. Let's see. This combination. I was thinking about doing this as well, but I didn't know how to do it. But that's not the part. That's the hard part. I think he just implemented some function that he knows. I don't know that one. Yeah, let's see. Let's see if I can just at least get a hint. This looks like DP. 20. Why is this 20? Max value. Max value. Why is this not max value square? I guess maybe it is, and it's just fast enough in C++. Is that it? This is just like the number of factors or something. I don't know this one at all. Like, I don't think I know the math for this one. Yeah, this looks like a very short solution. Like, why is this fast enough? Why is max value? square fast enough, right? Like, I think that's the problem that I don't know. And what does this mean? Yeah, I mean, that's just I don't know that I know this one. There are a lot of I was thinking along these lines, but maybe I just don't know how to do it. We were talking about this choice thing. But I still don't have any idea. I feel like there's something very mathematical about this. So I guess that makes sense. I I always forget to keep track of the number of factorizations, but okay. I think I have an idea because Josh told me. So basically, if you look at what we had before, and can I come back? I don't know if I could go all the way back. Undoing. Because we have that recursion, right? All right, friends. Why is this Python thing showing me like weird code? How do I reset? Okay, I think I get the idea. Let's see if I can do it with. Let's see. Right, so we have. This is a very hard problem. I have to think about it again. Okay, I think I have an idea now. Basically, for each number, we just sum it up for the last element. Okay, so okay, let's see. Let's say we have this number. We have let's say the current value, and then let's just say factors. do you even, this is so weird. Sorry friends, I'm just trying to upsolve this 350. Well, a lot of people got this. I'm kind of impressed, to be honest. I mean, I even knowing the answer, I'm like struggling a little bit, maybe. Hmm. Like like this is not an easy problem for sure, but a lot of people got it. Do people just know how to do these things? A lot of a Python solution. Okay, let's just actually do this. Okay, from yeah, whatever. 1 to max value plus 1. And I think I just needed one idea, and I think the idea that I thought that it wasn't gonna be fat. Oh, I see. Because I had both the ideas, but I didn't put it together. That was my issue. So yeah, it's already sad, but not. I mean, not that sad, like I said. So. Okay. Let's see. Maybe this is too much. So 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I guess this is right. I mean, I think I need to add itself, but that's okay. And now it should be in order anyway. Okay. I mean, this was actually pretty fast to getting all those 10,000 things. Okay. And then the key observation that I missed is that we can do max of length of f for f in factors. So then we can kind of see how many factors we have. And 64 is the biggest one, isn't it? Is that right? Maybe I missed that. Oh, do I want all the factors or the primary things? Because then, okay, so how do I do pause? Right, so I go, okay. Okay, I see. So then we do a pause and stars or whatever on the last number, but I don't really. Even knowing the idea, I don't have it, to be honest. So I need to be better. You know, practicing more a little bit about this. The factors is 64, but do I need prime factors? Is that the thing? Because we just got 2, 2, 2, 2, 2, so that's just one. Actually, I don't know that I know how to do this part. or rather, I don't know how to tie them together. I think I have. Like, how do we know how many paths there are? Oh, you get DP to get the number of counts of. Okay, wow, that's really hard. I think I thought about this, but I thought that would be, or maybe I just didn't think to try it, to be honest. Okay, well. Yeah, okay. Let me give me a second, let me think about this. So basically, okay. So basically for a given number, what does that mean, right? How many ways are there to get from, okay, so okay, I think I okay, I think I have for each number for each number x, how many ways are there to have y distinct paths? Okay. Or have a distinct or a path with y elements. Okay. And because this will be at most 60, we should be able to do it for every number. Okay, let's try it that way. As we said, the number is going to be 64. But yeah, okay, let's see. Right, so then left, if left is equal to 0, we return 1, and then otherwise we go for I in for x in factors of x. No, that's just terrible actually. For y in factors of, so this is a factor, we take this path and then we subtract by 1, right? And this can be 1. If x is equal to 1, we return 0, right? Okay. I know I have to do mod. Hang on. Okay, and then now we do for so then it'll be 60 square square or something like this. Okay, so something like this. 1 to max value plus 1. Let's just have some fun to see what would work, or just to see if it's fast enough. So go of I and then yeah. Length of factors of I. I don't know, just kind of, let's see if this is fast enough. Okay, so this is actually it's fast, so that's good. Actually, I know that this isn't the right answer, by the way. So then that means that, okay, This isn't quite right either though, because we want actually for j in range of this. It looks really yucky. Also, I may have been off by 1 anyway, but yeah, maybe it's fast enough because it reuses a lot of things, right? Yeah. Oh, this is actually not quite right. Hang on. So we want to have one number, okay, one number, and we go to 1 and 0, 0. So if left is 0, 0, that's fine actually, because it doesn't have. No, is it? If x is, if left is equal to 0, it doesn't have itself, right? No, it does have itself. Okay. Let's figure it out. Okay, so then that means that now there goes up, there's this amount, and then it's this amount times basically choose of this I plus 1 bars, and then j maybe something like this. Yeah, okay, so there's I sub 1. No, that's not right. That's what we do have is n plus 1 space and j numbers in that path, right? Okay, I think this part is right, and therefore now just all right, let's see if this is still fast enough. Okay, that's still pretty okay. Way 1, but okay, well, how did I even get this high? What am I doing? Let me see if I could debug this part, because this is just too high to be true. Let's see. What am I doing here? Uh-oh, I might have printed that too much for the other one, but that's okay. I think I got it now. Oh, I got the idea. We have to finish it, but this is hard. Okay, so 1, 1 is 0. That's actually not true. What is 1, 1 again? For each number, for 1, how many is it? 1. So left is. And this actually should not contain itself. So I think this is off by 1. Yeah, so this should be j minus 1 maybe, because it assumes that the first number is already I. This is the last number. So the last number is x, but left minus 1. Okay, maybe this is a little bit better. So that just means that the number will be even bigger. Oops. Okay. 1, 1 is 1. The 2 with 1 left. Okay. Okay, here. 4 and 3. What's 4 and 3 again? For number 4, how many ways are there to have 3 elements? For the number 4 in the path of 5. That's weird, right? Because basically I'm just saying, okay, there's 4 to have 1 element would be 1 way, okay. Because it's just 4, 4, 4, 4, 4, 4, 4. And then 2 elements is 4, 2. So there's 2 ways. No, is there? No, there's only 1 way. Okay, 4, 2 is 1, but it's showing 3. That's why. Okay. Why is that? Because it includes itself. It should not include itself. That's why. Okay. Yeah, I should not have done all that, to be honest. Or like the 10. Okay, let's remove this case for now, and then we can have meaningful debugging. So 4, 1 is 2, 4, 2, okay, and there's no 3 factors, so that's right? 5 is 1, okay. And then now we have to choose this thing, and this thing, that's what, I mean, that part I knew. So yeah, fact is equal to 1, fact is equal to 1, actually this is not true, but okay. what is it? It's negative inverse of, how do I do modular inverse again? Today I am not great. Okay, so yeah, we do 1 to -1 of prime. Okay, the prime is what I forgot. Okay, and now for I in range of from 2 to max value plus 1. Oh no, we want it to n. So yeah, for n plus 1, fact append fact there's 1 times I. Yes, and then I fact is equal to fact of the new fact -1. -1 mod. Okay, and then choose of this is just factorial. Oh, I have to mod this. I think last time I forgot to mod too. Yeah, and then here we just have factorial of x times yeah, how do I do this again? Is this right? I don't even know anymore. And then something like that. My mind's a little toasted, but that's okay. Let's see. Is that right though? I mean, this will have to be 2 times n plus 1. That's fine. But why is that then? Tell me why. Okay, this is way wrong, but okay. And choose 1 is and choose 1 is n factorial 1. Okay, why am I doing this? Okay, I'm just way tired, I think. Okay, this is slightly better, but maybe I'm off by 1. Is this n plus 1 given n numbers? And we want to choose. Now we want to choose. Okay, the boss is going to be j minus 1, and then the number of spaces is n plus 1. Maybe it's n minus 1, or just n rather. Okay, that's very wrong. Let's think about it again real quick. Also my oh no, this is right. Oh, I forgot to do the j minus 1 here. That's why, because I printed it out but I got it wrong. Okay, so is this still n plus 1 maybe? Nope. Okay, what is going on here? Oh, max 3. Oh, I forgot the 1 case. Do I not have a 1 case? Maybe I do have a 1 case. Okay, well, the 1 case is just everything is 1, right? So we'll just do it 1. Okay, fine. Okay, I mean, I think we're close, but this is kind of super tricky. Maybe I'm off by a little bit. I think that, let's see. Okay, so we have a sequence of n numbers, right? I have to prove everything. This is very sad, actually. There's one way of doing 4 choose. Is it 4 choose 1? So you have 4 numbers and you have 1 digit, right? So that means that you have 0 degree of 4 digits. Yeah, and then, but or 4 slots, or actually 5 slots, or n plus 1 way to put 1 slot, right? To put 0 slot. Okay, I feel like this is right though. This idea anyway. Maybe I made this part wrong. Let's double check real quick. I am ready, whatever today. Why is that? Okay, it goes out of bounds for whatever reason. let's just say, yeah. Okay, so 0 choose 0 is 1, maybe that's fine. 2 choose 1. 2 choose 1 should be 2. Did I mess that up? Did I mess that up? 2 choose 1 should be 2, right? So why is that such ridiculousness? So it's 2 factorial over 1 factorial and 2 factorial, right? 2 choose 1. Oh, no, 0 factorial, but 0 factorial is this ridiculousness. That's right, right? It's just 1 over 1. What is the... Yeah, that's just 1, right? So I factor of 0 was I factor of 2. So this is half. This is... What? I can't believe I'm debugging this part. Usually I'm pretty good about this, but maybe not. Maybe just not today. So it's 1, and then this is 1 over 2, which is fair. But then, oh wait, I messed up. Okay, I mean that's an easy fix. I just forgot the one case. Okay. I mean this is still wrong. I thought I was close, but at least we fixed this part, I think. Yeah, no easy buckets. 2 chooses 1. Yeah, there's 2 ways. 2 chooses 2 is 1 way. Okay, so at least that part's right. But now we still have issues. So let's take a look. Okay, let's see. This way is 6, right? So this is 1, 2, 3, 4. Why this it goes to 11? Did I mess up a case? I mean, I add 1, that's why. But so 4. Let's see. Maybe I'm messing this up. So 4 case. 4 is the big one. In the 2 case, did I have an extra one? 4 exactly 2. Oh, I see. Because now you cannot, it's not n plus 1 slots, it's n minus 1 slots, because we're forced to have, we cannot get it at the corners. Okay. Okay, I think that makes sense actually. Okay, I mean this is slightly better, but still wrong clearly. 4, there's only 1 slot, and 2, so that sounds right. Sound with, no, there's 3. So 4, no, 4 with 2 numbers is 2. That's right. Why do I only have 7? What is this j minus 1 again? J minus 1 is the number of divisions on whatever, so okay. So what should this be returning? Okay, so for the 5 case, it should be 2. Every one of these should be at least 2. Because, well, with 1 number, and then I think I have to do an extra number. That's why. This is actually wrong. Because 2 has 2, 2 and 2, 1. No, 2 with 1 number is just 2. But then you also have to do 2 with 2 numbers. Because I'm forgetting, yeah, okay. Because I'm forgetting the number where you go back to 1. Maybe. But then now I'm a little bit awkward. Let's see. How do I say this in a good way? Maybe this part is a little bit weird actually. I think maybe I'm closer now, but it's basically the idea is that you use this number, but you still want to be able to go to 1. Which I guess we do go to 1. Maybe this is wrong actually. Okay, so then for each factor, we're getting closer. And this is me with the hint, so it's very sad. Let's see, right? Okay, so we start with 4, and we want it with 2 distinct numbers. There's 4, 2, and 4, 1, right? And then for each of these, we have 2 numbers. So it's 2 choose 2, which is equal to 1. Yeah, makes sense. And then 4 choose 1, which it, oh no, the 4 with 1 number is only 1, and you can, it's 2 choose 1. No, it's 2 choose 0. 2 choose, wait, no, okay, so if there's 2 distinct numbers, then, oh, I see, I'm not just minusing the beginning. Okay, I see. So I is going to be equal to j, I think, because for each of these you can think about it as, yeah, okay, maybe not. Maybe I'd add 1 though, because basically there are n numbers and n plus 1 space slots. Is that true? My bars and stripes are terrible today. Okay, if we force that j numbers, okay, so we're forced to have j numbers, have j distinct elements, then what happens, right? And in a n thing, so that means that we remove j, but then now we have plus 1, now we have plus 1 freedom. What am I off by? Yikes. Like for example here, right? We have 3 numbers, or the last number is 3. We want 1 number. No, we want 2 numbers. That's why we're not calculating the 3 and 2. Because it only has 1 prime factor because it doesn't have itself. Is that why? Do we not add 1 here? Alright, let's print it out. What am I doing? I factors of I. Oh, it doesn't have itself. So then that thinks that this is just 2, so it only has 1. Okay, is that right? I removed that the itself part, but I think I could just confuse myself. Okay, I think this part is now right, maybe, because you have 2 numbers. Yeah. Maybe. Okay, 4 with 3 numbers is just 4, 2, 1, right? Which, oh no, there's no, because it's 2 choose 3. So yeah, if x is greater or less than y, we return 0. Okay. Okay. This is way yikes, but I think I got it, even though this is way slow. I think the big part was just not, oh, I should have tested the 10,000 case. Maybe a time limit. Oh, that's even worse. Let's actually take a quick look. I mean, and I get to judge for free, so this is just actually sad because I would test this and I'll be like, oh, this is wrong. Okay. Back to the drawing board. Oh no. Okay, let's take this out. I mean, I think like we're close, but not quite. Okay, so 5. Let's try a smaller number to see if we like, is this right? This is right. Okay, let's say we have 3 numbers and 9. Okay, so this is wrong. This is good because then now we have a smaller example to kind of go by. So we have 3 numbers. Max value is 9. Right, so 9 we have 3 numbers. This should not be 0. Right, so we have 0 choose. This part is wrong. I think that's probably why. Because we should have 0 choose 0, but this may actually be 0 choose like 2 or something, which is why this is wrong. Man, my bars in stripe math is so bad. Because basically you have 3 numbers and you have to put 3, so then this is, yeah. But then what if you have 4, right? Then you have, that means you have 1, and then okay, maybe I'm just really wrong on this one. But okay, basically the idea is that, yeah, maybe why am I so weird on this one? Should it just be n plus 1? But I had it before like this, right? My math is just so bad. Okay, let's say we have 4 numbers. We forced 3 of those numbers. So then we have 1 number left. So then that would, and that could be in anywhere really. So how do I make that true? It's not 4 choose 3. Is it? Because then we're forced to have 1 number. So then now we have 1 choose 3 choose 1, I guess, but still, how do I do it? Stars and bars. I keep saying bars and stripes, but okay, because we're forced to choose 1. How many gaps are there left? Was it not? My math is so bad. Either someone like this, or am I thinking crazy? Which, to be honest, is not reasonable. Okay, yeah, that's just too much. Wow, I'm just messing up on the last part. Okay. So let's say we have 4 elements. I forgot the part where you're forcing every element to have 1. So basically, yeah, you're still doing the dividers of J. I think this is just J dividers maybe. I'm just testing random things now. I feel like I'm a little bit bad about this. Oh, okay, come on, Larry, focus. Let's visualize. So now let's say you have 4 space. Let's say you have 4. So then you have 1, 2, and 4, but you have 4 slots as well. So that means that your combinations are 1, 1, 2, 4, 1, 2, 2, 4, 1, 1, 2, 4, 4, and then here you have. What does that mean in terms of bar? Basically, you have here you have 2 things, and then you have. Basically, we want this to be either this, right? We want, I forget how to do it so that you have at least 0. I think maybe I have to subtract something. So I have to subtract this from the case where because I could have just done Googling. Maybe I'm just a little bit bad today. I am very bad at math, friends. Also very tired. I can't believe I can't get this part. Okay. So basically, yeah, 4, 3. Yeah, what's number of digits? Actually, there's only 3 numbers. So 3 numbers, 3 true. What would I do? 3. I mean, of course, this is going to be 0, but basically, I'm even wrong on this one. I'm just getting wrong on straight up here, and then how do I even do this again? So n is equal to 3, so this should return just 1, but instead I do 0, because let's see, where's the 3, 4, yeah, 3, 1, and then I just return 0. 1 choose 3 for some reason. How do I get the I feel like I've done this one before. I'm just so bad today. Sorry, friends. Is it just n on this side? Is that it? Did I confuse myself? That's way too big. Okay, so for 4 we have 3, 1, and we get 3, 1, we get 10. That's not right? I'm just trying random stuff. Sorry, friends. I know I've been apologizing a lot today. Maybe this as well. No. Sorry, friends. I'm just actually reading bars and whatever, stars and bars. Also, I think I got the original one wrong, but because I think this is right for not non-zero or with 0, because then now this would have 3, but then now this should be minus j minus 1. And now it doesn't make sense. I mean, this n and j minus 1 is the same anyway, so it doesn't really change the thing. All right. That's really weird. Why is this different from before? Whoops, I printed it. We got the right answer. Okay, so I spent a long time on this type. I wouldn't call it a typo, but on bad math. Why is this n minus 1? Oh, because I thought I tried this. That's why I didn't try it again. But I thought we said that there's n plus 1 space, but then we removed the ones from the corner. Because basically, yeah, I got confused. Because here you have some digit A, B, C, D, and then here. So that's normally how you do. There's 5 spaces, you choose 3 of them, right? Or something like that for n is equal to 3. But then now we remove the 2's, and that's how you get n minus 1. But I thought I tried this, that's why I didn't try it again. But I think I'm just confusing myself too much today. Cool. Yeah, I mean, I'm going to do a video on this. Hope if you're watching here, leave a comment about leave me your favorite Marvel movie, or just tell me you don't like Marvel movie, just so that I know you're watching. Give you mad props if you do. But yeah, that's all I have for this one. That's all I have for this contest. Yeah. I'll see you later. Yeah, hit the like button, hit the subscribe button, join me on Discord, let me know what you think about these problems. Need your love, need your support. This is a tough week for contests for me. So anyway, stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.